All right, good evening and welcome to today's class. Um, Last time we had a class here, we discussed complementary angles under trigonometric ratio. Sorry, under trigonometry, exactly. Um, um, at this point, we define that the two angles are said to be complementary when their sum is 90. All right. Now, along the line, we obtained a particular identities that is still found within the trig ratios. We got identity for sine and cosine, all right? And that was where we ended our last week class because, sorry, our last class because those identity was what I wanted us to actually achieve so that by the time we start working with them subsequently, we actually know where they came from. Is that okay? All right. Today let's actually make do of those identities by solving some examples today. Okay. Now the first example here it says that sine theta is equal to cos 35. In other words, we are going to find the value of that. What's it called? Theta. The next says that sine alpha is equal to cos 3 alpha. Okay. So at this point, you're going to really know what that what was it called? What that alpha really stands for. All right. While the last one said that cos x is equal to sine into bracket x plus 22. So you're going to really know the value of that x that made both sides to be equal. Remember, they said that the left hand side and the right hand side are equal. So until you get to know the value of theta, you cannot really believe that. Okay. So let's actually go and get the value of each of those unknown in each of those numbers. Let's actually go. First, let me list those identities that we obtained in our previous class. The first identity says that sine theta is equal to cos into brackets 90 minus theta. While the second one says cos theta is equal to sine into brackets 90 minus theta. All right. So these are the two identities that we obtained in our previous class. Now let's solve. The first one's I says that sine theta is equal to cos 35 degrees. Okay. Then we recall that sine theta, or don't let me just waste much time here. This is equal to this. So I'm going to replace this with this in this I. Sin theta was it called? Sorry, sin theta is equal to this. So I'm going to use this to replace this one. All right. So when I do, I'm going to have that I will be solved this way. Instead of me writing sin theta, I'm going to write cos into bracket 90 minus theta, which is cos into brackets 90 minus theta, then is equal to 30 cos 35 degrees. Now at this point, I will strike away the cos. So I'm going to have 90 minus theta is equal to 35. Okay, so I'm going to have it this way, that 90 minus 35 is equal to theta. Therefore, 90 minus 35 should give me 55. Therefore, theta is equal to 55 degrees. That means that for this side and here to be the same or to be equal, theta must be 55. Okay, that means sine 55 is equal to cos 35. You can go and try it on your own. All right, now let's continue. The next one. The next one is sine alpha is equal to cos 3 alpha. Okay, now recall that this is equal to this. So I'm going to replace theta with alpha in this case. Okay, so I'm going to have cos 90 minus alpha to be equal to this. So let's go. I'll have cos 90. Sorry, we are used to theta already. Is equal to cos theta. Sorry, cos alpha. Oh my God. There's an error here. Pardon, let me just strike it out. The second one should be II. I'm going to have cos into bracket 90 minus alpha is equal to cos 3 alpha. Is that okay? So this go with this. I'm left with 90 minus alpha is equal to 3 alpha. Okay, at this point let's collect like terms. So I'm going to have that 90 is equal to 3 alpha, then plus, okay, plus alpha. Are we together? Okay, let's continue. So I'm going to have that 90 is equal to 3 alpha plus alpha is 4 alpha. Okay, now the next is to divide both sides by 4. Therefore, I'm going to have 90 over 4 is equal to 4 alpha over 4. So this cancel this. I have that alpha is equal to 4 can go in this. Okay, 4 divide 8 here. Going to get 2 to remain 1. 2 remain 1. That one comes here. That is 10. Right? So 2 in what's it called? 2 in 10 will actually give me, sorry, 4 in 10 give me 2. Right? Remain 2. So that 2 could be called 20. So that means 4 in 20 is 5. So alpha becomes 22.5 degrees. All right. Now the third one. The third one says, what's it called? Third one says cos x is equal to sine into bracket x plus 22. So we need to get the value of x for us to agree that this side and this side are equal. Okay, at this point, recall that cos x is going to give us sine into bracket 90 minus x, not more theta at this point. Okay, so I'm going to have sine into bracket 90 minus x is equal to sine into bracket x plus 22. Okay, so this goes with this. I'm going to have 90 minus x is equal to x plus 22. To collect like terms, this comes to meet 90. So I'm going to have 90 minus 22 is equal to x becomes plus. So I'm going to have 90 minus 22 should give me 68. X plus x is 2x. So to get my x, I divide both sides by 2. 2 cancel 2, that means x is left. Therefore, 2 in 6 is 3. 2 in 8 is 4. So x is equal to 34 degrees. All right, that is that about this. We'll still get more to work on probably tomorrow. Okay, but meanwhile, kindly go through these examples, master them, and expect your exercises. Thank you and bye for now.